In this lesson, we are going to learn about table management of delta tables. We will cover deep copy and shallow copy of the tables and the managed and unmanaged or external tables. So, to start with the deep or the shallow copy or the deep or shallow cloning. So, what is deep cloning? So, deep cloning is a clone that copies the source table data into the clone target, which means let us say we want to create a copy of an existing table. So using deep clone, the entire data and the metadata of the table will be copied to the destination table. So this is deep clone. So the command for deep clone is create table, target table name, clone and source table name. Remember that when we don't specify the type of cloning in the syntax, by default it is deep cloning. Means by default entire data will be copied from source to the destination table location. Coming to the shallow clone is a clone that does not copy the data files to the clone target. So and the syntax for this is create or replace table, the target table name, shallow clone and the source table name. So in shallow cloning we need to specifically mention that we need to do shallow clone. In shallow clone the data and the metadata from the source table will not be copied to the target table location. To explain further the difference between the deep copy and the shallow copy, I will take the help of this diagram. In this we can see on the left hand side we have the base table, in middle I have the deep copy and then the shallow copy. So in this example the base copy has three versions, version 0, 1 and 2. We can see each of the version has the corresponding files in the data folder and in the delta log folder. So when we create the deep copy from the version 2, the deep copy will copy the data files and the delta log files from version 2 base table into its own folder. So this is deep copy. However, in case of shallow copy, when we create the shallow copy from base table version 2, no data files are copied. Only the log files are copied as of version 2. So these log files are still pointing to the data files of the base table. So in shallow copy, no data files have been copied. Further, let us say there is an update to the base table and version n is created, which means there will be more files in the data files or there will be updates in the delta log files. But the shallow copy will still point to the version 2. So shallow copy is not impacted by further updates of the base table. Similarly, deep copy when this table is updated, it will again update its own data files and the delta log files. So no impact if the base table is updated. Next scenario, let us say we go and delete the base table or we do a vacuum so that version 2 does not exist any longer. So in this case, deep copy version 2 will still be valid because the data files were copied. However, in case of shallow copy, because there were no data files and the delta log was pointing to version 2 data files, if these data files are deleted, version 2 shallow copy will not be existing. It won't respond. So this is the impact of further updates to the base table. What are the differences between the shallow copy and the deep copy? The copying behavior that we have discussed creates a new object referencing the same memory location in case of shallow copy, whereas in deep copy it will create an independent copy of the original object. In shallow copy, only the top level object is duplicated. It will not duplicate the files. The top level only contains the version number and the delta log. it will contain the version information, not the data. So actual data is not duplicated. So the nested data objects are still referenced. In case of deep copy, it will copy the entire object hierarchy. The memory consumed is very less in case of shallow copy because it is just a pointer. In deep copy, it will require the memory to store the copy data. Again, in case of performance, shallow copy is fast because it is pointing to the original table. In case of deep copy, it could be slower. Then the next is managed and unmanaged table. What is a managed and what is unmanaged? So this is the diagram of the Databricks architecture that we earlier discussed. If you remember, we said it is divided into two parts, the control plane and the data plane. The control plane has the web application, consumer notebooks, job and queries and cluster management, and the data plane holds all the data, whether it could be AWS storage, Azure or Google Cloud. I am not going into nitty-gritties of this architecture, so I will be discussing the managed and the unmanaged table. So when the data is managed by Databricks within its DBFS file system layer, which means Databricks will will decide where the table is going to be stored. We are not going to specify any external location within AWS or Azure. Databricks will manage those tables. However, when we create a table, we can say create a delta table and create at this location, which means file data for that table will not be managed by DBFS, or data will not be managed by Databricks. It is our responsibility to manage that data. We will specify store the data in external location. It could be in S3 blob storage or in Google Cloud. These tables are called as the external tables. When we do not specify any location while creating the table is managed by Databricks, and those tables are called as managed tables. What are the differences between managed table and external tables? So the storage location, managed table is stored in DBFS, where external tables are not stored in DBFS, they are managed by us in the external storage system, but still within the cloud storage. Then the life cycle of the managed table is managed by Databricks, and for others, the external table, we need to manage the life cycle. Then metadata, this is stored in the Databricks meta store. For external tables, we have to maintain them separately. We need to separately register those tables in the Unity catalog. Then portability of the managed table data is limited because we do not have access to that data. That data is restricted, the access is restricted, and we are unable to go into that data and delete those files or copy those files independently. We will have to use Databricks commands through Databricks data plane or control plane. Whereas in case of external tables, we are able to go into the, let's say, ADLS Azure blob storage or AWS S3 buckets. We can copy and can manage those data. So higher portability in case of external tables. In case of performance, the Databricks managed tables are high performant because they are optimized by Databricks runtime. In case of external tables, because we maintain them, so performance can vary. The backup and store in case of managed table is automatically backed up and restored in case of the managed tables, whereas in external table it is our responsibility to back up and restore them. In case of cost, the managed table, they are included in the Databricks platform cost because Databricks is storing them. Databricks is going to charge us. In external tables, the cloud provider, let's say AWS, Azure or Google Cloud, they are going to charge us. That will be a separate bill apart from the Databricks cloud environment usage. See you in the next lecture. Thank you.